Okay. Cylindrical coordinates are theta z. Okay. Represent a point corresponding to polar coordinate r theta down here in the plane, just your familiar polar coordinates, and your z coordinates the same as for a point for the xyz representation, right? So if your rectangular coordinate representation is xyz, what is r, what's theta, okay? Now you started to tell me that r was x cosine theta. Well, you know, you got the right idea, and you know, okay? But you know, x would be r cosine theta, and y would be r sine theta. That's the easy one. I didn't ask you that one, because I know you know that, okay? I asked you this one. I'm pretty sure you know at least how to get r. You might have to think a little bit about how to get theta.
Theta would be the inverse tangent of y over x, right?
Almost. But the inverse tangent only gives you angles between negative pi and pi. Okay? So anyhow, r is x squared plus y squared. If we know polar coordinates, this is, I mean, you know, it's something we're supposed to know at this point, right? Saying you pretty much do, but really you got to internalize it. Just a little better. And you want to say theta is the arctangent of y over x. That's fine if theta is between negative pi over 2 and pi over 2. Plus pi, or 180 degrees, depending on what coordinate system you have to be using. If x is less than 0. Because, of course, x is greater than 0 between negative pi over 2 and pi over 2. For everything else, x is less than 0, and you better add 180 degrees, and you work out y. Okay?
Because it'll be negative.
Huh? If x is negative, you're going to have to go 180 degrees from whatever the arctangent would tell you. And that's so obvious that I'm not even going to explain it. Okay? If you don't understand why, you can still use the rule, but then you're acting like an engineer. Okay? Not visualizing, you're not seeing what's going on. But you can still get the right answer. So I don't recommend that approach, but it's okay to start by getting the right answer and then think about why that's the right answer, right? But if you never do that, you're acting like an engineer who's not as good as he or she should be, right? Okay? Okay, well, then if you're given r and theta, and of course, z is z in either case, right? So there's a complete set of relationships between rectangular coordinates in 3 dimensions and cylindrical coordinates, okay? Okay, well, let's look at maybe an example of a way we would use cylindrical coordinates to set up an integral, okay?